Welcome back. This section is titled Designing an Open Bowl for Wet Wood Carving. The oval bowl is most common, but requires a deceptively accurate process for design, as the human eye is built to find anomalies in orientation and irregularities in shape. This means that inaccuracies in an oval's changing curvature can be visually jarring. This requires that we use a process that passes the visual test for uniformity in its gradual transitions and curvature, and that the same process can be used for both our rough carving and our finished carving for each bowl. Additionally, this process must be anchored in simple geometric concepts which, if used properly, allow a predictable and precise result. So, why is a new process needed? When I started there, I could only find one way to precisely design an oval bowl, which is this. It's called the two-pin method because we set two pins into the wood, and with a string created as a loop, and then a marking pin attached, we move the drawing pin around, and the tension on the string gives you a perfect oval. And there's a whole body of math around this simple concept. So far, so good. And if you have a dry block of wood, this approach works fine, and you can use the orientation of the pins to find your center lines. You can use those center lines to install handles with the proper orientation, flip it over, get those orientations to the bottom, and you can now design feet. You can add additional embellishments. You've got everything you need. But what do you do with the two-pin method on a wet block of wood like this one? Anyone using a wet block of wood to make a bowl, whether by a hand carving or by turning on a lathe, knows that the bowl must be twice turned. This means you must have a way to redesign the bowl once it's dry. Here's a bowl taken from our drying closet. It was designed using the techniques that will be shown in this presentation, and it has handles and it's got feet. As happens with all bowls that are newly dried, the shape has changed from when it was rough carved. It's now no longer level and flat. It's got areas that are wide, it's got areas that are narrow, it's got areas that are high, it's got areas that are low. We've got to redesign this bowl. We've got to both reflatten and make parallel the tops and bottoms, and then we have to put our design back onto the bowl. But there's a problem with the two-pin method. There's no place to put the pin. There's a hole here. Second, without your pins, there's no obvious way to redesign or to define the center lines that you need to properly place and orient feet and handles. That's why a new process was needed. One that could be used both in the initial wet, rough carving and then re-engage when the newly dried bowl comes out of its closet. My search and experimentation led me to a set of approaches that are effective, quick, and reliable. Importantly, with them, the fun of bowl carving returned. So let's dive into that process now. As you will soon see, my process for designing ovals is based on circles of different sizes and the ability to draw perpendicular lines. What you see here are several groups of items. In the back are my third generation of drawing arcs that I have recently purchased from a company called Craft Cuts. My second generation arcs were fully functional, handmade large arcs, measured and cut from a large sheet of construction cardboard, but were getting worn. Before that, my first generation large arcs were simply garbage can lids, pots, dinner plates, and so on. The point being that when you're getting started, be creative. Each arc in the photo is based on a segment of a circle labeled for the size of the circle from which each arc is derived. This assortment will give me arcs that correspond to the curvature of a 2-foot to a 10.5-foot circle in 1/2-foot increments. To the right of those is my collection of smaller circles, also from Craft Cuts. These start with an interior diameter of 2 inches, and the largest of these have an exterior dimension of 22 inches. Together, I have all sizes between them in 1-inch intervals. Moving forward in the photo are some other items collected from plastic food containers and some white circles made by using Microsoft's Word program. These are created for those occasions when I needed a circle of a unique size. I use this common word processing program to quickly and accurately create a circle of selected diameter and then print it on cardstock for cutout. Using a standard 8.5 by 11 paper, I can make a circle up to about 10 inches as a side that is often expendable. Finally, on the left are a framing square and a carpenter square. These allow me to transfer midlines from a bowl's top to its bottom or to design rectangular bowls. This black item is my line squaring tool, which I made from a purchased piece of 1/8 inch thick, durable yet flexible plastic that was cut square to 6 inches by 12 inches. You can see I made two cuts with a bandsaw in the middle of each of the longer edges, one extending down about an inch and the other extending up about 3 inches. This has been a very valuable tool to make perpendicular lines. By sighting through the cuts when set on a line, the top and bottom side of the line squaring tool will be perpendicular to that line. I can then confidently draw a 12-inch long second line that is perpendicular to the first line. This tool makes designing feet and second midlines both fast and accurate. At this point, I'd like to introduce the process of easily creating mathematically precise and easily reproducible ovals for rough and finish carving. I will start with a set of animations to introduce and demonstrate the concepts, and then I'll show a couple of designs that resulted on carving blocks. There are many ways to draw an oval, with the two-pin method being only one. Because of its shortcomings, experimentation led me to seek ways to create an approach that was quick, accurate, and reproducible, even if I only had access to the rims of a bowl. Critically, it had to meet the eye's requirements for seeing a pleasing oval, and it had to permit the easy and precise placement of centerlines. To be useful, placing these centerlines had to be anchored in geometric theorems so that I could confidently scale my ovals to fit whatever wood I was working on. Because it has strict drawing protocols, I needed a name to differentiate it from the other ways of drawing ovals, so I call this the Nicasio Oval. The simplicity and value of this should be clear when I demonstrate its use on a bowl after it's dried. That will be discussed in Chapter 7. Let me show you how it's done. The process is based on the geometry of circles, employing two different diameter circles, or sections of the circles, placed tangentially to each other. Using the smaller circles, we draw the east-west ends of our oval, shown in blue. The larger circles are used to draw our oval's north-south sides, shown in purple. You can see that they're being drawn tangent to the blue east-west circles. Drawn as tangents, the eye will be unable to tell exactly where the curvature changes, so you'll only see an oval. The new bowl's rim is defined by each circle up to the point of tangent, where the new circle takes over. This can be seen in green. A critical feature of this technique is a simple and reliable way to find centerlines. These are found by merely drawing a line connecting to the 2 points where each circle intersects their partner. Note that the precision of this technique for finding centerlines is guaranteed by two different groups of geometric theorems having to do with mirror images and radical axes. Drawing these is straightforward on top of a flat carving block. However, using some simple hacks anchored in the same geometric principles, we can produce the same precise results on the relatively thin rim, newly dried bowl later on. These will be presented in Chapter 7 when talking about redesigning the newly dried bowl. Center lines are critical if you want to add anything to your oval, such as handles, feet, or other embellishments. So let's look at how we translate these center lines, first to some simple handles and then to some basic feet. Note that considerable variation is possible within these simple approaches, and for entirely different approaches, some examples of which you can find on our website at nicasio.woodworks.com. For now, let's look at the simple options, and I'll describe some of the many variations that are possible for each. With the shape of the bowl designed, I want to illustrate 3 styles of handles, all quite simple to both design and carve. First is a standard end handle drawn on the bowl's narrow east-west ends. The simplest illustration of these requires 3 choices. First, how long will the handles be? Second, how wide are the handles? And third, how do you want to transition from the bowl to the handle? The process is merely to measure your desired distance, and at that distance, draw a perpendicular line to the east-west center line to make the proper handle width. This process ensures that the handles are oriented to the bowl. Finally, we transition from the bowl to the handle by using a modest-sized circle, guiding our drawing of an arc that's tangent to the edge of the bowl's rim and terminating at the handle's corners. Variations include having the handles be above, at, or below the rim, or to have handles that curve up or curve down, or to change the shape of the ends of the handles, for example, making them curved instead of straight. Next are handles for torpedo-shaped bowls. These offer the easiest handles to design and carve because we merely extend the north-south sides to their convergence beyond the outside of the bowl's basin. The result is that north-south lines become the bowl's exterior surrounding the interior bowl. A simple variation on this is to truncate those pointed ends to make flat-ended handles. These handles can either retain the north-south curve all the way to the end as shown, or we can create transitions from the bowl to the handles, just like in the prior example of end handles. Just as before, these handles can be above, at, or below the primary rim of the bowl and can curve up or down. Next are side handles. These are quite easy to design, but take a bit more care in the carving. Here, our east-west and north-south arcs remain as the outer profile of the bowl, but now we change the shape of the interior of the bowl by drawing straight lines, tangent to the east-west circles. These are shown in blue. The resulting bowl will now contain a more narrow basin, shown in dark blue, inside the wider bowl's exterior profile, shown in green. I have on several occasions substituted the east-west tangential straight line with another arc. The key is to use a low-slope arc to leave enough room for the resulting side handles to be meaningful. As with all handles, side handles can be above, at, or below the rim of the bowl based on your personal choice. Obviously, many handle options exist beyond those demonstrated here, but with these, you can create a visually wide variety of bowls, all based on an oval. Let me bring some of the issues out of abstraction. Here are two carving blocks with their intended oval bowls designed. This first example is a block of loquat wood on which the design was created by combining an 8-inch circle and a 2-foot arc, shown here connected at their tangents. This bowl will sport side handles, taking advantage of the lighter sapwood on the outsides, which will be contrasted by this loquat's complex pink interior. This acacia block has been designed to become a fairly simple oval bowl. Here I used a 7-inch circle on the ends, bounded by a 2-foot arc, each converging at their respective tangents. The handles chosen here are flat-ended handles, arching out from the bowl's exterior. You can see my carving lines inside the design lines. This is the closest I'll come to the rim during rough carving. If you look closely, you'll see that I elected to use a concave arc to transition from the bowl's body to the end of the blunt handles, just like presented in the first of the handle animations. Finally, we need to draw the feet. While feet are optional, we almost always add them because they are not difficult to make and they allow the bowl to stand proud of its surface, which offers a better presentation. Importantly, if the bowl is placed on a damp counter for a period of time, only the feet get wet, not the entire bottom of the bowl, which would risk warping the bowl. Because the bowl blank is flat and parallel, we can easily transfer the center lines from the top to the bottom with a carpentry square or any other item that allows you to make a perpendicular line from the top center lines to the bottom. Then, connecting those lines across the bottom provides both center lines and the center point. Feet are then measured from these, both to define how far apart to place them and how wide they should be. Here, simple rectangular feet are being shown, but of course they can be curved, trapezoidal, made as 4 separate small feet, etc. Here the loquat center lines have been extended down the sides to the bottom. The cracks on the top surface have led me to design the bowl's rim to be about 3/4 of an inch below the tops of the side handles. The feet were designed as small arcs, specifically a 9 and a 7-inch arc. Here you can see the design of the acacia bowl's trapezoidal feet. Proper orientation is achieved by extending the bowl's top center lines to the bottom. You can also see my estimate of the carving lines for the bottom of the bowl. In this image are the same two bowls, after I spent just a bit over an hour and a half to get them both rough carved. You can see the same lines and that my rough carving is staying wide of the lines. Note that the loquat's basin is both a different shape than the bowl's exterior profile, and it sits about 3/4 of an inch below the handles. Note also how the acacia bowl sides transition to the wide handles. Now with the oval bowl design drawn on your bowl blank, you're ready to proceed to rough carving. However, the next 2 presentations in this series look at non-oval bowl designs, specifically triangular and rectangular. Note that the rough and finish carving issues will be the same, whether oval, triangular, or rectangular. These 2 additional design presentations can stand alone, so feel free to skip ahead to section 6 on rough carving and drawing. I will see you in your chosen next step in this series.